Okay, this is the solution to exam number 2. Alright, so actually it's the first 4 problems of exam number 2. Alright, so let's get started. So in the first one, we're looking at sum of currents going into a node. So the sum of currents going into a node is equal to the sum of currents going out of the node. Alright, this is Kirchhoff's current law. Alright, and if we take the sum of voltages, voltage rises, around any loop, that should be equal to the sum of voltage drops around that loop. This is Kirchhoff's voltage law. Okay, the next one, we're looking at thermal resistance, and you need to keep track of units, and the way we'd get started in this problem is thermal resistance is delta X over Ka, for K is thermal conductivity. Okay, so we know our units for thermal conductivity are BTUs per hour per foot per degree Fahrenheit. So to make this formula dimensionally consistent, delta X needs to be in feet. Okay, so we have it in 0.25 inches, and then we know there's 12 inches in 1 foot, so we've converted that to feet. All right, so plugging that in, we get 0.25 divided by 12 divided by K, and then the area is 4 by 8, so that's 32 square feet. And we get this number, 0.0065. All right, so looking at the units, if we're looking at R, we know X, delta X has to be in feet. We know K is in BTUs. Okay, then it's per hour, so hour goes on top. Per foot, so foot goes on top. Per degree, degree goes on top. All right, and so then we divide by the area, which is square feet. So we notice that feet all divide out, and our units are degree Fahrenheit per BTU per hour. Okay, so there's the solution to number 3. Number 4, you didn't actually need to compute the resistance of these 2 wires. What you need to know is, let's use a water flow analogy. If I have a pipe of a certain diameter, which is it easier for water to flow through? Right? We can get a lot more water through a larger diameter pipe than a smaller diameter pipe. Same thing happens for wire. So the least resistance is the one that has the largest diameter. So that would be AWG10. Okay, so there's the solutions to the first 4. I'll do other video solutions to the remaining problems.